In this lesson, we're going to begin a series of lessons on exponential functions. Exponential functions are like linear functions and are used to model situations. Exponential functions are used to model situations that either grow or decrease very rapidly. The general form for an exponential function is y equals a times b to the x power. So in our first bullet point, we can fill in an exponential functions are defined by an equation in the form y equals a times b to the x power. So just like with linear functions, when you have y equals mx plus b, we're talking about the same thing, except for with exponential functions, since it changes in a different way, we need a different equation. With exponential functions, if your b value is greater than 1, the function is an exponential growth function. And we also say it is increasing. If that b value is less than 1, it's an exponential decay function. Or a function that is decreasing. There are a lot of characteristics with exponential functions. One of those is called an asymptote. An asymptote is a line on the graph which the graph gets closer to but never reaches. So it's going to be a point on your graph that you see it approaching and it gets closer and closer and closer, but it never actually reaches that point. Let's take a look at a few examples of some exponential functions and talk about some of their characteristics. Our first exponential function is y equals 2 to the x power. So when we look at this, we can see that the b value is 2. So because that b value is greater than 1, we can say that it is a growth function, or it is increasing. So we want to go ahead and graph it and show that it is that growth function. So we're going to start by making a table of values. And you can use your calculator to help you make the table of values. What you're going to do is take our exponential function of 2 to the x power, and you're going to replace the x with an x value. A good range of x values to use would be -2, -1, 0, 1, and 2. This gives you a good idea of how that exponential function moves in both the positive and the negative, and what it looks like at 0. So what we're going to do is replace x in our exponential function first with -2. Then we're going to replace it with -1, 2 to the -1. Then 2 to the 0, 2 to the first, and 2 squared. So we're taking that same exponential function, just replacing the x with different x values. And we type those into the calculator. So when I type in 2 to the -2 power, I get a decimal, 0.25. When I type in 2 to the negative 1 power, I get another decimal, 0.5. 2 to the 0 power, remember anything to the 0 power is 1. And then 2 to the first power is 2. 2 to the second power, 2 times 2 is 4. So now that I have these points, I can graph these 5 points and see what our graph looks like. I'm going to start at the bottom of my graph and graph those whole numbers first. So my point 2, 4, starting at my origin, going over 2 and up 4. The next point, 1, 2. Again, starting at the origin, going over 1, up 2. 0, 1, staying at the origin and going up 1. Now with the other two, we have to estimate about where it would be because they're decimals. So starting at our origin, we're going to go to the left 1, and then we're going to go up just a half. And then negative 2, 0.25, we're going to go to the left 2, and then up just a fourth. So again, just estimating where those are. Then we can connect our dots to show that this is an exponential function. You can also type into your calculator y equals 2 to the x power and see this graph as well. So we've already talked about that we know that this is a growth function because that b value was greater than 1. Now remember, domain talks about our x values and range talks about our y values. So if we take a look on our x-axis and where we have a graph, everywhere that I move up, my line hits the graph somewhere. So everywhere on my graph, I have an x value. So we can say that my domain is all real numbers. Now my range is going to be different because with my range on my y-axis, we can see that my graph gets close, but it never reaches. It never goes down there into the negatives. So my range is going to be a little bit different. Range is y, and it's a y value, anything above 0. So all of these up here and continuing on. So we can say that my range is y is greater than 0. We wouldn't say greater than or equal to because it's approaching 0. It never actually reaches 0. The next thing we want to identify is our y-intercept. So remember your y-intercept, let me rewrite this in a different color. Remember that your y-intercept is when x equals 0. So there's a couple ways you can find your y-intercept. You can look at the graph and you can find that point where it crosses your y-axis. You can also look at your table and find that point where x is 0. So my y-intercept is the point 0, 1. That's where my exponential function crosses the y-axis. And then the last thing, your asymptote. That line where your graph is approaching but never reaching. So that line is here. And the name of that line is y equals 0. Let's take a look at another example. Number 2. Y equals 1/4 to the x power. So in this example, our b value is 1/4. So we can say that b is less than 1. So that means this is going to be a decay. So when I graph it, what I should see is that it's going down. We're going to create a table of values. Again, I'm going to use the values -2, -1, 0, 1, and 2. And we're going to put this into our calculator to calculate it. So we're going to take 1/4, making sure we put it in parentheses. We're going to raise it to the -2 power. When I put that in the calculator, I get 16. We're going to do the same thing for -1. 1/4 in parentheses to the -1 power. And you see you get 4. Then 1/4 to the 0 power. We shouldn't need a calculator for that because we know anything to the 0 power is itself. Anything to the 0 power is 1. Then 1/4 to the first power. So anything to the first power is itself. We're going to write that as a decimal. So 1/4 is 0.25. Or you can put that in your calculator if you need to. And then 1/4 to the second power. So again, putting that in your calculator, you get a decimal, 0.0625. So now we're going to graph it. So my first point, -216. We're going to go over 2 to the left and up 16. And it goes off of our graph about here. Then our next point, -1/4, at my origin, go over 1, up 4, 0, 1. And then again, for your decimals, you just have to estimate. So over 1, up 1/4, over 2, up not even 1/4. And then we can connect those. And we see it's kind of doing about the same shape. It's approaching that x-axis again, but not exactly quite reaching it. And again, you can put y equals 1/4 to the x power in your calculator, and you can see this graph also. So, like we already talked about, this is a decay. Our domain, again, is all real numbers. Remember, our domain is our x values. So anywhere along this x-axis, if I go up, I hit my graph. Even out here where you can't see it, you know eventually it's going to hit that graph. Then your range, which is your y values. So again, this is approaching 0. It doesn't go into any of my negative y values. So none of these. It's all above 0. So my range is going to be y is greater than 0, just like with number 1. Your y-intercept is going to be 0, 1. Again, you can look at your graph at that point that it crosses your y-axis, or you can look at your table where x equals 0. And then your asymptote is y equals 0. It's where that graph is approaching your x-axis but not exactly reaching it. Let's take a look at one more example. Y equals 3 to the x minus 1. So again, we want to take a look at our b value, which is 3. So our b value is greater than 1, so we know it's a growth. And we're going to make a table of values to help us graph it. And we're going to use the numbers -2, -1, 0, 1, and 2. So putting into our calculator, this one's a little bit more complex. 3 to the -2 minus 1. And you can see for this one, we get a decimal, and it's a repeating decimal. So we'll write that as -0.8 repeated. And then 3 to the -1 minus 1, again, is another repeating decimal. -0.6 repeated. And then 3 to the 0 power minus 1. Well, we know 3 to the 0 power is 1, and 1 minus 1 is 0. But you can also put that into your calculator. And then 3 to the first power minus 1. 3 to the first power is 3. 3 minus 1 is 2. And then 3 to the second power minus 1. 3 squared is 3 times 3 is 9. Minus 1 is 8. So I'm going to start from the bottom of my table and graph those points going up. So my first point of 2, 8, go over 2 and up 8. 1, 2, over 1, up 2. 0, 0. And then again, for my decimals, I'm going to have to estimate them. So over to -1 and down to about a half. And then over to -2 and down to almost -3, but not quite. And then graphing it, we can see, remember you read a graph from left to right, so we can see going from left to right, it's moving upward, which makes it a growth. Our domain again is going to be all real numbers, because as we move across that x-axis, we can always hit our function. Our range in this one's going to be a little bit different. So we know range is y. And if I look at my y-axis, it's all of my numbers above -1. So it's approaching -1. So it's going to be y is greater than -1. So you want to look at that line, that value that it's approaching. And then our y-intercept, again, we can look at our table or our graph. Our y-intercept is 0, 0. And then your asymptote, that line that it's approaching, is y equals -1. Go ahead and highlight number 4, 5, and 6. And remember to use those values, -2, -1, 0, 1, and 2 when making your table.